Right guys, so this is the remainder of higher tier paper 1 from June last year. This is the mock that you did recently. If you want the first half, okay, I only go through the second half now. If you want the first half, have a look at the intermediate video from about question 10 or 11 is the first half of this paper. I'm going to do the second half now. I didn't want to do it twice. Okay, so just looking at the second half, very straightforward. Okay, we're going into the more difficult stuff now, but it's not too bad. Okay, so all this question is asking you, okay, using the axis below, you should find the region which satisfies the following inequalities. Okay, so you just plot in 3 lines. Okay, I'm going to plot the lines x equals minus 2, y plus x is 1, and 2y is equal to x. Right, so first one, x is equal to minus 2. Okay, that's an easy line to plot. Okay, we're looking for the x value minus 2, which is there. Looking for the x value minus 2, which is there. And we need to plot a straight line going straight through that. Okay, so x is minus 2. It goes like this because all the points on this line are minus 2. Okay, and it goes to the x-axis. Okay, it's a very straightforward line, the first one. Okay, they're all thick back lines because it's greater than or less than or equal to. So that's your first line done. Next line, y plus x is equal to 1. It's that because y plus x is equal to 1. I'm going to draw this on. It's that because if you've got a y value of 0 and an x value of 1, it's going to be equal to 1. And if you've got a y value of 1 and an x value of 0, it's still going to be equal to 1. So these 2 points you can plot on straight away, and it's going to be a straight line. So it looks something like that. Okay, last one is the 2y is greater than x line, okay? That's an easy one. I don't like it in this form, okay? So what I'm going to do, I'm going to rearrange that to give me y equals x over 2. Because whenever I'm drawing lines, I always have a single value of y. I'm going to put my table out the same way you would on drawing any linear line. X values and y values, okay? I give myself x ones and I work out my values for y. Okay, x, I'm just going to pick 0, 2 and 4. It could be any points at all, but I'm going to pick those 3. If my x value is 0, the y value is x divided by 2. 0 divided by 2 is just 0, so that's easy. If I'm going to pick my y value, it's just x divided by 2. Here's my x value. If I halve that is 1, and I halve that one gives me 2. So these are 3 points on this line. Now if I draw them on, I've got 0, 0, which is an easy one. I've got to go across 2 and up 1, by there. And I've got to go across, not by there. I go across 2 and up 1 by there, and across 4 and up 2, which is by here. Can I just draw a straight line? Probably you want to do it neater than I have. I just do a straight line through there. Now once we're here now, the last bit, the inequalities bit, okay? This is the bit you want to get right. We want the points greater than minus 2. X is greater than minus 2. So we want the points, there's x is minus 2. We want the points greater than that line. So anything below that, and it's going to shade it. Okay? Second one, we want the points y plus x is less than 1. So we want the points less, this is my line here. We want the points less than below that. So I'm going to shade above it. And my last one, 2y is greater than x. We want the points above that line because we want the ones greater than, so it's going to shade below it. What you'll end up in is a shape and a region you've indicated. It's just the stuff that's left, and that's that whole question done. Next one, right, rearrange the following formula to make x a subject. Okay, rearranging is easy. Okay, bear with me 1 second, I've got a bit of a cold. Rearranging is easy. Cx take away 3 equals 4x plus d. Now what we want to do, we want to get all the x's on one side and all the letters that haven't got an x in it on the other. Okay, so I'm going to take this 3, I'm going to rewrite this underneath here just so it's bigger. Cx take away 3 equals 4x plus d. I want to get this 3 over the other side, so I'm going to add 3 to both sides. And it was Cx plus 3 minus 3 go, 4x plus d plus 3. And then I want to take away 4x on this side because I want it on the other side. Take away 4x. And it was Cx, take away 4x, is equal to d plus 3. Now, solving equations is very straightforward, okay? It's exactly the same thing as you were doing before. exactly the same thing. Okay, rearranging and solving have the same rules. Okay, now I've got this to here. Now I need to get x on its own. Okay, so if you look at this one by here, you think back to basic algebra. I've got to take x outside the front of the bracket, so it's basic factorising. X on the outside. If I take x on the outside, these two x's go, and it was c take away 4 on the inside is all equal to d plus 3. Once I'm there, I want x on its own, so I'm going to divide by c take away 4 to both sides. X equals d plus 3 on the top, c take away 4 on the bottom, and that's it. You've made x a subject. Okay, that's job done. 3 marks. Over here in the following diagram, A and BD are straight lines, and BC equals CE. So these two lines by here. Now, is it possible to conclude that triangles ABC and DEC are congruent? You must show all your work in and explain your decision. So there's a couple of rules for congruency. All congruency means is the triangles are the same. You need to find two angles and a side that's in between them to make it that are identical to make it the same. 3 angles all being the same, or 3 sides all being the same, or a side, an angle, and a side. So there's a couple of ways we can do this. Okay. So what I'm going to do first, I'm going to label what I know. Okay. Explain your decision. This bit by here, I know this. These are 2 lines meeting, and these 2 are opposite angles, so that's going to be 83 degrees. Okay, so that's 83 degrees. So I don't know what you want to call it, but you can say that opposite angles. Opposite angles are equal. I like to label my diagram so I can see what I'm working with. Okay, from here now, what I've got over here, I've got angles in a triangle. So angles in a triangle, I know angles in a triangle make 180. So I know I can find this one. If I do 83 plus 65, it gives me 148. And then if I do 180, take away 148, I end up with 32. So this angle by here is going to be 32. And you'd say because angles in a triangle equal 180. Okay, so it always comes back to the basic rules. Okay, angles in a triangle equal 180. Once I'm here now, these sides are the same. And I've got 2 angles on either side of the identical sides that are also the same. So I can conclude at the bottom, 2 angles and a side in between are identical on both triangles. Therefore, congruent. Okay, and you can leave it like that. Okay, they're congruent because there's 2 angles and a side in between that are the same on both. Okay, therefore they're congruent. Express this as a fraction, right? Easy question, okay? Expressing a recurring decimal as a fraction. This little dot means that 8 is going on forever, okay? So the way I'd write this is 0.24888 going on forever and ever, okay? What I'm going to do, I'm going to form this into an equation. So I'm going to call this x. X equals 0.248888 going on forever. Now, the 2 things that I need to do, I need to get the recurring decimal over the decimal point, and I need to get it up to next to the decimal point. It'll make sense why I need to do that in a second, if I want to make it into a fraction. Now, if I want to get it over the decimal point, I need to times by 1,000. So 1,000x, if I times that side by 1,000, if I times this side by 1,000, I end up with 248.8888 going on forever. Okay, that doesn't stop. Then if I want to get the first one, if I want to get the recurring decimal up to the decimal point, I've got to times by 100. 100x equals 24.888888 going on forever again. Now the reason I did what I just did, okay, I got it over the decimal point and got it up to the decimal point. What you'll see is you'll notice that they match. The numbers after the decimal point on both things match. Now I did that because I want to get rid of the recurring stuff. If I want it as a fraction, the recurring stuff can't be there. Okay, so what I'm going to do with these two, I'm going to take them away from each other. 1,000x take away 100x is 900x. 248 take away 24 is 224. And this stuff on here, because I'm taking it away and it's the same, it'll just cancel out. So 900x equals 224. If I divide through by 900, I end up with 224 over 900, and that will cancel down to, I believe, 56 over 225, if you keep halving it. Okay, really straightforward one. Okay, one you could quite easily learn. Down the bottom, there's loads going on here. Okay, I've got three things going on. I've got this minus bit by here, which is important. I've got the squared bit on top and the root that's underneath on the bottom. So the minus, all that means is you're going to do the reciprocal of what you've got going on. The bit on top of the fraction is just a normal power, so that would mean squared. And the bit on the bottom is your root, okay, if it's on the bottom of a fraction. Okay, that number 3 means I've got to cube root this when I get there. Okay, so I can do these in any order. Okay, it doesn't really matter which order you do them in. I'm going to do them in the order that makes them gives me the most simple answer. So I'm going to start with the minus bit. If I do the reciprocal of 1 over 27, it just gives me 27. So 27 to the power of 2 over 3. Okay, once I've used something, it goes away. When I'm here now, I'm going to do the root next to make sure I've got an easier number. If I square it first, I'll get a much more difficult number. If I do the root, if I cube root 27, 3 times 3 times 3 is 27. So my cube root is 23. Leaves me a 3 squared. And 3 squared is easy, just 3 times 3 gives me 9. Okay, very straightforward question. Okay, just make sure you understand your rules of indices. Over here now, I've got a bit of circle theorems, okay? Not that difficult a question. Okay, there's just a couple of basic rules you need to know. What is good is it doesn't say state your rules as you go. Okay, it just says show you working. Okay, so I like to draw on the diagram. It's up to you how you do it. You can draw on a diagram if you want to. Okay, if I've got two tangents touching a circle, okay, that would mean these two lines are identical, and that would mean these two angles are also identical. If these two angles are identical, that means it's an isosceles triangle, and finding out what they are is really straightforward. Okay, so I'm going to do 180, take away 58. Gives me between 1, 2, 2. And then if I want to find what these two angles are, I've got to do 1, 2, 2 divided by 2. 2 doesn't go into 1, 2 goes into 12, 6 times goes into 2 once. So I've got 61 on this side and 61 on this side. Okay, that's straightforward. Now, the only real circle theorems one you need to know is that alternate segment theorem. So this angle by here is the same as this angle by there. So that's 61 as well. Okay, you can write that down if you want to. It's not the end of the world if you don't. I'm missing this angle here. They want to know the angle ABC, so they want to know this one. And I'm just left with angles in a triangle. So 61 plus 35, 6, 9 is 96. And then 180, take away 96. Is 84. So this angle in here is 84. Okay, so very straightforward. You just have to learn your circle theorems. Okay, guys, there's a page of them. Learn them off by heart. If you'd have known that was an isosceles triangle and known alternate segment theorem, should have been a straightforward question. Okay, question 14 on a higher tier paper. Right, guys, so surds are really easy. Okay, simplify square root of 45. When you do in surds, you've got to try and break the number underneath the square root down into one square number, and the other number is just a normal number, okay? So my square numbers, if I think about them, okay, I've got 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 49, 36, 49, 64, 81, and 100, okay? They're my first 10. Okay, I'll write those down. It's good to have those written down so you know you can use one of these numbers from this list and you've got to use just a normal number, okay? Square root of 45. If I was to break it down using one of the numbers of these lists, from this list, and just 45, thinking about what I could use, okay, 45, I know, looking at this list, the only thing I can really use is the number 9. So I can break square root of 45 down into 9 times 5, similar to the way you would on factor trees. Okay, square root of 9 times 5. This, I can't get a square root of this. That's something nice. But I can get square root of this. Square root of 9 is just the number 3. Now, if you want to square root that, you bring the number you've square rooted it to out the front. So the 3 comes out the front. And the 5 still stays underneath my umbrella. Okay, so 3 root 5. Now, I've got that answer by here, so that's lovely. That's sorted. Right, this one by here now. All this is FOIL. You're following the same rules as you would with normal surds, but it's just FOIL. Okay, so it should be quite straightforward. So I got 2 root 7, take away root 3. Now squared, all that means is times by itself, so I got 2 root 7, take away root 3. Okay, so same thing, so just literally following the rules of FOIL. First, outside, inside, last. Okay, the first two things in both brackets. Okay, I've got 2 root 7 and 2 root 7. If I times those two things by each other, the two front numbers, 2 times 2, you can bring those out the front and you can times those two together. And the root 7s you can also times together. 2 times 2 is 4. Root 7 times root 7 just leaves me root 7. Just leaves me a normal 7, sorry. The square root cancels each other out. 4 times 7 gives me 28. That's the first one done. The outside edges, okay, so these two by here, the outside edges. So you got 2 root 7 times by minus root 3. Now, a minus times a positive just gives me a minus answer. If I've got two numbers that are both underneath my umbrella and my square root, I can just times them together. So the 2 stays at the front just as a 2, not going to mess with that. Underneath, I got 7 times 3. 7 times 3 is just 21. Okay? Now, you'll notice on the inside edges, it's almost exactly the same. It is exactly the same. So I've got root 3 times 2 root 7. So I'm going to write that down again. This gives me minus 2 root 21. So that's exactly the same. Exactly the same as my outside edges. And my last, root 3 minus root 3 times minus root 3. Minus times a minus makes a positive. And root 3 times root 3 just leaves me a positive 3. So if I've got all this now, I've got a positive 28, I've got minus 2 root 21, minus 2 root 21, and positive 3. So I'm going to write that down together. So I've got 28, minus 2 root 21, minus 2 root 21, and positive 3 in the end. Once I'm there now, I can put the 28 and the 3 together to make it 31. And the 2 root 21, you've got to think of these root 21s like almost like x values. Okay, if you've got minus 2x and minus 2x, that's going to leave you a minus 4x. So in this case, it's going to leave us a minus 4 root 21. And that's your final answer. Okay, we're nearly at the end. So, root 16. The diagram shows a cylinder. Okay, the cylinder has a base of radius r and a height of r over 6. A sphere has a radius r, so big R. So it's a little bit different to little r. The volume of the sphere is equal to the volume of the cylinder. Okay, I'm going to write that down because they told me it. Okay, volume of sphere. Now, before I go on, if you turn back, it's in the front page. Volume of sphere is 4/3 pi r squared. So I'm going to write that down. Pi r cubed, I think. Let's look back. Pi r cubed. 4/3 pi r cubed, yep. And then volume of a cylinder is whatever the area of the top face is. It's the area of the top face. So area of a circle is pi r squared, so pi times r squared, times by the height. So all times by r over 6. Okay, once we're here now, we should be able to get some of this. So all I'm doing from here, I'm just solving an equation and simplifying as best I can. So my pi's will cancel out. So if there's a pi on this side and a pi on that side, they're both equal, they'll just cancel out with each other. If I times through by 6, so if I times both sides by 6, if I times this by 6, it'll get rid of this divided by 6, so times by 6. If I times this side by 6, what will happen is this will turn into an 8. R cubed will stay there. Is all equal to r squared, that's not going to move. Times by r, so that's going to be r cubed. All divided by, the divided by 6 just cancels out. So 8 r squared times by r cubed. Now this r, because it's the volume of the sphere, and they've told us the volume of the sphere has a radius big R. This r I'm going to write as big R, and I'm going to write it as big R by here as well. So that is big R. So 8 r cubed is all equal to little r cubed as well. So once we're here now, because these are different, I can't cancel them out. I'm going to divide through by 8. Now we want to find out what big R is, so big R equals, if I want to get rid of this, I've got a cube root. Once I'm here now, this isn't my final answer, okay? So big R is equal to cube root of little r cubed, all divided by 8. Now, it's not my final answer. I can cube root the top, just leaving me with little r. And I can cube root the bottom, just leaving me with 2. So big R is equal to little r over 2. It is a lot of complex rearranging, guys, so just you have to bear with yourself on that one. And the following diagram shows a sketch of the curve y equals fx. The curve is transformed as shown below. So you can see, if you're looking at the two of them, okay, it is a curve, but the same rules apply with curves and with straight lines, okay? It's exactly the same thing. If you look at the top, my function is y equals fx, and the bottom, it's gone from intersecting at 0, the curve hasn't changed, but now it intersects at 2. So if it's gone from intersecting at 0 and to intersecting at 2, all it's going to change is y equals, my function stays the same, but now it's intersecting at 2. So the intercept on the end has got to change to a positive 2. Over here now, the following diagram again shows a sketch of a curve y equals fx. So my curve starts by here. If you look at the one on the bottom, the points haven't actually changed. The curve has just been flipped on its side. So all the x values, if they were positive, they've gone to negative x values. If they were negative, they've gone to positive. Okay, so the curve is just flipped. Now, if you're doing anything to the x values, okay, that's the stuff inside your bracket. Okay, that's the stuff inside your bracket. So if I'm going to flip every single x value, I've got to times every single x value by minus 1. So if I times these by minus 1, they'll turn to positive. If I times these by minus 1, they'll turn to negative. So y equals f minus 1 times all the x values on the inside. And that's it. (18a). A box contains 4 yellow cards and 6 red cards. 3 cards are chosen at random, 1 at a time without replacement. Calculate the probability the first 2 cards are yellow and the third was red. So this is a little bit of common sense. Now if you're working out the probability of stuff and it's occurring one after the other, the probability of picking a yellow card in the first instance, is 4, because there's 4 yellow cards, out of a possible 10. Now that's the first one. On the second pick, now you've got to remember at this point now, 1 yellow card is gone and 1 card has gone off the total. So first 2 cards are yellow. If the second card is yellow, it's going to be times. The yellow cards have gone down to 3 because I took 1 on the first go, and it's out of a possible 9 because the total's gone down by 1 as well. So instead of on the first go, 4 out of 10, this time the total of the yellows has gone down by 1 and the total altogether has gone down by 1. The third card being red. Remember the total of reds has not changed yet because I've picked 2 yellows. So the third card being red is still 6. The probability of picking the number of reds is still 6. The total though, I took 1 on the first one and made the total go down to 9. I've taken another one now, so the total has now gone down to 8. Once we're here, just times the top times the bottom. 4 times 3 gives me an answer of 12. 12 times 6 gives me an answer of 72. And down the bottom, 10 times 9 is 90. 90 times 8 is 720. 72 over 720, that does simplify down to 1 over 10. Okay, down the bottom. Okay, calculate the probability at least 1 yellow card is chosen. So, if you're working out the probability of at least 1 yellow card, okay, that's an easy probability to work out, but there's loads of different ways you can get one yellow. The best way to do it is to think about what's the probability of not getting a yellow at all. The probability of not getting a yellow at all is the probability of picking reds times 3. So picking 3 reds in a row. That's the probability of not picking a yellow. Okay, now remember probability has to add to 1. So if I did 1 whole, take away the probability of picking three reds in a row, that would get me my answer. So it's a different way of thinking about it, but it'll take less working. Okay, so 1 take away, probability of getting 3 reds in a row. Red on the first one is 6 over 10. Red on the second one is 5 over 10. Red on the third one is 4 over, not over 10, 5 over 9 is 4 over 8. Okay, because remember the total goes down by 1 each time. So 6 times 5 is 6 times 5 is 30, times by 4 is 120. 10 times 9 times 8, remember, it's the same as before, just gives me 720. Now this fraction, 120 over 720, it just simplifies right down to 1 over 6. 1 take away 1 over 6, just leaves you a 5 over 6. Okay, very straightforward question. Okay, it just takes a little bit of thinking. Again, you've got to think a little bit outside the box with it, but again, it's just basic probability. Last two. Okay, now you're following the simple rules, but it is algebra. Okay, so when you're taking away fractions, if you think about thinking back, if the bottoms aren't the same, you've got to cross multiply. Okay, so I've got 1 x take away a, take away 1 over x. Now the bottoms aren't the same on my fractions, so I'm going to times the bottoms by each other. This is what you'd normally do when you take away fractions. I times the bottoms by each other, I end up with x take away on the inside of the bracket, and then I cross multiply. So x times 1 is just x over 8 times 1 is just x over x take away a, and take away goes in the middle. So x take away x should leave me with just a, and x times x is x squared, x times a is minus ax. So my answer is a on the top, all over x squared take away ax. Right, very last question now, 19b. So this is a little bit of rearranging, okay? To solve this equation, okay, you need it all on the top. Okay, don't want I got a fraction by here, I don't like it, okay? So what I'm going to do first, I'm going to take away 2 from both sides. So with x, take away 1 on this side, x, 4x plus 3, all in the bracket, is equal to minus 2. Okay, so first part then. Then I'm going to times through by this bottom bit. I'm going to times by x, 4x plus 3, times by x, 4x plus 3. I know with x, take away 1 on the left hand side, minus 2x, 4x plus 3 on the right hand side. Once I'm here now, I expand my bracket. So I know x take away 1 equals minus 8x squared, take away 6x. Once I'm here now, I just want to take everything over the other side. So it's going to be minus x and add 1 to both sides. So I end up with 0 equals minus 8x squared, minus 6x, minus 7x, and take away 1 on the end. Add 1 on the end. So once we're here now, so I got 0 equals minus 8x squared, take away 7x plus 1. I don't like the x squared bit at the beginning being minus, so I'm going to take it over the other side now. So I end up with 8x squared plus 7x, take away 1 is all equal to 0. Now it's a bit cramped at the bottom, but I'm going to try and finish my work. And remember, you've got an extra page on the other side. If you look back to the front of the paper, okay, what you will have quadratic formula. Okay, what that is right down the bottom. It's a really easy topic to learn. Okay, so it's this stuff down by here. So my formula is this. I got x equals, so my x values are equal minus b plus or minus b squared, take away 4ac, all over 2a. Okay, that's my formula. Okay, now my a value is the number in front of the first x, my b value is the number in front of the second x, my c value is the number on the end. So all I'm going to do is substitute these values into this formula, and it should give us a fairly straightforward answer. So minus b, so minus 7, plus or minus, what that means is you've got to do it once with a plus and once with a minus, square root b squared, so 7 squared, take away 4 times by 8 times by minus 1. All of this is divided by 2 times 8. So minus 7. Now what I'm going to do, I'm going to tidy up the inside of the square root. Okay, so I've got 7 squared, take away 4 times 8, times minus 1. All of these times, these minuses, okay, these two by here, they're going to cancel out to make a plus. So 4 times 8 is 32. Minus 1 times by the front will make it plus 32. 49 plus 32 is positive 81. So square root of 81. All over 2 times 8, which is 16. Okay, so I've got minus 7 plus square root of 81, which is 9, all over 16. So minus 7 plus plus 9, which is positive 2. 2 over 16 is 1 over 8. And then I'm going to do the same thing with a minus 7. Take away 9 all over 16. Gives me minus 16 over 16, which is minus 1. So my two answers are minus 1 or 1 over 8. Okay, move that over a little bit. Okay, so guys, if you enjoyed this, okay, you found it useful, please share it with your friends. If you found any of this difficult, okay, that's okay. This is a higher tier paper, so you are finding it hard, that's all right. Again, please take your time with it. Do one question at a time. If you're struggling with a topic, please take the time to learn it for yourself, okay? Take it, go away and relearn it yourself. If you have found this useful, please follow my Instagram and subscribe to my YouTube.